So our lesson for today is about cosets, normal subgroup, and quotients group. And our learning objectives: at the end of the lesson, the student must be able to: first is define cosets, a normal subgroup, and a quotient group. Second is to determine if a subgroup is a normal. And third is to determine the cosets and the quotient group in a given subgroup. So let's begin with cosets. So in Lagrange theorem states that for any finite group G, the number of elements of every subgroup H of G divides the number of elements of G. And then there are two types of cosets, the right and the left cosets. So when we say right cosets, it is a subset of the form HG is equals to HG such that H is an element of H for some G is an element of G. And if we add the elements from the right, then we call it the right cosets. And then likewise, the left cosets is a subset of the form G of H is equals to G of H such that H is an element of H for some G is an element of G. So, and if we perform the operation to the left side, so normal subgroup. It is a subgroup that is invariant under conjugation of any members of the group of which it is parts. A normal subgroup if and only if G in G minus 1 is an element of N, for all G is an element of G, and for all N is an element of N. So when the left cosets and the right cosets of a certain subgroups are equal or the same, then we call the subgroups a normal subgroups. So let's proceed to quotient group. So quotient group is a mathematical group obtained by aggregating similar elements of a larger group using an equivalence relation that preserves some of the group structure. The rest of the structure is factored out. So if we consider a set with the elements being the normal subgroups and its cosets, then we call it a quotient group. So for this example, how do we determine cosets, a normal subgroup, and a quotient group? So let G is equals to Z sub 8 and let H be a subgroup that is equal to 0 and 4. So we will list the coset of 0, 4. So first thing to do is list all the elements in the group. So Z sub 8 is equal to 0, 1, 2, 3, 4, 5, 6, and 7. So these are now our element in a group. So to list the coset of 0, 4, we will just be adding every element of the group to our cosets. So we have the element of 0, 1, 2, 3, 4, 5, 6, and 7. And we will adding to our cosets 0, 4. So 0 plus 0 is 0 and 0 plus 4 is 0 and 4. Next is for 1. 1 plus 0 is 1 and 1 plus 4 is 5. So it will become equal to 1 and 5. So 2 plus 0 is 2 and 2 plus 4 is 6. So we will have 2 and 6. So if you have 3, so 3 plus 0 is 3, and 3 plus 4 is 7. Equal to 3 and 7. So if we have 4 plus 0 is 4, and 4 plus 4 is 8. So 8 minus 8 is 0. So we'll have 4 and 0. So if we'll have 5, 5 plus 0 is 5, and 5 plus 4 is 9, and 9 minus 8 is 1. So 5 and 1. So if you have 6 plus 0 is 6, and 6 plus 4 is 10. So 10 minus 8 is 2. So we'll have 6 and 2. So if we will have 7 plus 0 is 7, and 7 plus 4 is 11. 11 minus 8 is 3. So we'll have 7 and 3. So now this is our cosets. So we can now determine the right and the left cosets. So if we add the element from the right, and we will call it the right cosets of the subgroups. So our right cosets are this one: 5 and 1, 6 and 2, and 7 and 3. And if we perform the operation to the left side, it is now our left cosets. So this is our left cosets: 1, 5, 2, 6, and 3, 7. So right and left cosets are equals. Left and then right is now equal. So identify the elements of quotient group Z sub 8 over the coset 0 and 4. So if we consider a set with the elements being normal subgroups and its cosets, we call it a quotient group. Therefore, Z sub 8 over the coset 0 and 4 will be equal to the left and the right cosets. So 0 and 4, 1 and 5, 2 and 6, then 3 and 7 is equals to 0 and 4, 0 and 4 plus 1, and then 0 and 4 plus 2, and then lastly 0 and 4 plus 3. So these are now the elements of our quotient group.